Okay, for today we're doing a little review of parametric equations. So parametric has not just a pair of equations, it's actually got three little equations. Look at this. I got a y equals an x equals, and notice those both have a t in them. They're in terms of t. And then we also have our time. I like to think of t as time. Okay, so our time goes from 0 to 2. So at time, the XY chart, really, really important. Everybody make one of those if you haven't already. At time 0, let's say that this was tracking the ball's height in the air. Let's say that the y equation was the height of the ball. In the past, you've only been able to handle one equation like that. You had the height of the ball at any given time, and that was it. A lot of people confuse the graphs that we used to do as like, this is the height, and this is how far away from you it was. No, 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 no. That was the time, and this was the height. And so when the ball hit here, that's not how far away from you it was. That's the moment that the ball hit the ground. So we can only really handle how high is the ball. Like when we were doing the tennis ball thing outside, do you remember that? Threw a tennis ball up in there? We did that, didn't we? Did we never do a tennis ball? I thought we did a tennis ball. Okay. All right. So then this would have been the other equation, which is just like, okay, what about how far away from you it is? Do you get what I mean? Instead of how high up it is, this one could be how far away from you it is. So it gives you more information. All right, so if I graph this point, I put in a 0, then you should have put 0 into both of these equations. Not this one. What would you do? 0 is less than or equals 0? That wouldn't make any sense. But you could put in t equals 0 here and here, and then I'd have x equals 0, and y would be equal to 4. Raise your hand if you had 0, 0, 4. Okay, awesome. And then what if we put in a time is 1? Put a 1 here, put a 1 here, and x equals 1, and y equals 3 plus 4, which is 7. Raise your hand if you had 1, 1, 7. Okay, good. And the third point would be 2, and if you had a 2 stuck in there, then you'd have 6. 3 times 2 is 6, plus 4 is 10, y equals 10, and x would be equal to 2. 2, 2, 10. Now, what do you actually graph? You graph these, and then you just label the spots as like t equals 1, t equals 2, etc. So let's graph those. 0, 4, everybody put a dot like right about here. 1, 7, let's say it's right about there. 2, 10, it's right about there. And this would be at, I'm going to label these in a different color, t equals 0. This is at t equals 1. And this is at t equals 2. Now I've got an x and a y and a time all on one graph. Do you get how that's kind of like more information than normal? I can say, where was it at time 2? And you can tell me two things. At time 2, it was at this, and I shouldn't have labeled the x there, my bad. X is here, y is here, sorry. And then that spot would be at 0, 4. No, that's 2, sorry, 2, 10. 2, 10, there we go. Too messy. Black's too easier to read, so I'm going to go with that. So at time 2, the x was 2 and the y was 10. Now, in this case, did you notice that the x and the t were always the same? Why? Because x was equal to t. Like it was a really easy one. All right, so that's graphing. Raise your hand if you feel like you could graph. All right, good. What if I give you 2 points? 2, 6. It starts at 2, 6. And it goes to 4, comma 9. See if you can write me this system of equations, parametric equations, that would do this. Hint, you always have an x equals equation, you always have a y equals equation, and you always have a t, which is like the sandwich. T is between this and this. Now you could make this super complicated for yourself if you wanted, but what would be the easiest times to use? Say it out loud. Don't be shy. Nobody knows, actually. Okay, 0 to 1. That's easiest. You start the experiment when the clock starts. Time 0 is when you start. And then it starts running, and then time 1 is 1 second later. The ball is somewhere else. You get to pick that, but I'm warning you, always pick 0 and 1, because your life will be so much easier. All right. Then, how do you write the equation for it? Well, where is x at time, like when you start? It's at 2 and 6. So why isn't that the final answer? Because that, if I just left it this way, then x is always 2 and y is always 6, and it never changes. Do you get that? Wouldn't make any sense. But it starts at 2 comma 6, and then it goes somewhere based on the time. How much did our x go up? From 2 to 4, it went up 2. 2t. How much did our y go up? Well, it went from 6 to 9. So that went up 3. So then this is a 3 right here. That system would go from 2 comma 6 to 4 comma 9. Prove it to yourself by making a TXY chart. What I'm trying to do here is just keep pounding on the stuff that you need to know for the parametrics test. I'm going to pause for a second. Actually, I think this is easy enough. We're just going to charge right through it. Megadishi, how would you figure out the first, what should I put in for t? Put in 0. Good. And what do you get for x? Yep. 0, 2, 6. And that makes sense. At time 0, it was at 2 comma 6. And then, well, don't just copy the other point down here. The point is to make sure your equation works, right? So we're putting the t equals 1 right here into the equation. And you should have got 2 plus 2 is 4. And when I put in 1 into the other equation, I get 6 plus 3 is 9. And 1, 4, 9, yay, it worked. Does that make sense to you? Let's see, if you really understand this, you'll be able to do this easily by yourself then. 0 comma 12 goes to 4 comma negative 10. Right? And the system of parametric equations that would make that happen, remember, you get to pick the t, but if you're smart, you're going to go between 0 and 1. So here we go. You should have started with an x equation and a y equation. And of course, those have to have a t in them. So we really should know our t, and I suggested that it's always smart to go between 0 and 1. Okay, next. You should have known that it started at x equals 0 and y equals 12. Then you should have figured out that this went from 0 to 4, so our x went up 4 over that first interval from the one point to the other point. So this goes up plus 4t. Okay, and then this one does plus, I say plus, but it actually went down because it went from 12 to negative 10 and went down 22. So then I'm going to actually change my plus to a minus. You could have said plus minus and it would have been okay. 22t. Now, if you are smart, you would check yourself with a txy table. Everybody just put in the 1 on the txy table. Act like it's a different problem. You're just putting a 1 in and just see what happens. You put a 1 in here, you should have got 4. And something's wrong. No, I'm trying to find this spot. So, okay, then I'm okay. 1 goes with 4. This is time 1. And that time 1, our x was 4. Dang it, that's, there we go. I had the x in the y spot. And then the y is going to be, let me see, I'm going to stick in a 1, and I get 12 minus 22 times 1, which is 12 minus 22, which is negative 10. And that means that at time 1, my point was at 4 comma negative 10. Okay, that is called writing a parametric description. All right. Next up, if I give you these two equations, x equals t minus 3 and y equals 4t minus 2. If I tell you that t is just an element of the real numbers, what? That just means that time can be anything. Right away, I'd be thinking, okay, well, I'd really like my times to actually be like between 0 and 1, something that's like kind of normalish, right? But what can I do with this? This is a parametric system of equations. What can I do to it? What would be a typical question they'd ask you? Yes.
The x's and y's.
Yes. Make it into just x's and y's. Might be thinking, but there's a t in there. Do you remember what to do? Raise your hand if you know the first step. Okay. Lita, do you remember what the first step is?
Yep. I decided to use x equals t minus 3, and I did.
You took that one,
Yep.
and you did what?
X plus 3 equals t.
So you basically solved it for t. And you'd have t is equal to x plus 3. Why did you do that? So wherever you see t, you can put x plus 3. Does that mean I could take this first equation then and say x equals, and replace the t with x plus 3, and then minus 3, and then x equals x? Hey, that actually makes sense, kind of, in a weird way, right? Okay. It's more valid when you do it to the other one. You take this one and you say, okay, I'm going to take this y and go y is equal to 4, and instead of t, I'm going to put x plus 3, and then minus 2. Oops, I put my parentheses wrong. Okay, and then I have y is equal to 4x plus 12 minus 2. Y is equal to 4x plus 10. But what's x equal to? Well, why would we want x equal to something? We've already got our equation right here. That's it. If you wrote x equals x next to it, could I argue with you? No, x clearly is equal to x, but that doesn't really help. You know what I mean? If I put it in this first one, I just get x equals x, which doesn't really tell us much. So yeah, it's that equation. But what? But it's different. These are not the same. The original one had more information in it. It had t's and x's and y's. It's like if you took a graph that told you the position of the ball in like 3 different ways, like how far it was from you, how far it was from me, and how far it was off the ground. They have lots of info, and you strip it back to just 2 pieces of info. At what time was it what height? It just simplifies the equation down. It doesn't tell you as much info anymore. I just want you to get, this is not like changing an equation from one form to another form and then it's the same exact equation. It's not. This has less info. One last thing. You'd need to bring this down, but would it make any sense to say t is a real number? No, there's no t in it. So t, remember that t is like x. So x is an element of the reals. This is called a domain. And I would like you, if you're lost in that, to just always set the default that your x will be the same as t. Yes? Can you say that? Oh, this symbol? Element of. That just means that if I had said it goes from negative infinity to positive infinity, that would mean the same thing as t is an element of the reals. This is the same thing. It can be any real number. All right. Now let's step it up a notch. What if it says y equals 4x plus x squared, and we're going from 1 comma 3 to 4 comma 10. Wait, I'm wrong. It can't be 1 comma 3. It'd be 1 comma. Well, how about you guys tell me? Lita, could you shut that door for us, please? Thank you. What would this have to be? This spot right here. JK. How did you get 5? Yeah. That's got to be a 5. Then how about the other one? If this is going to be 4, let's stick a 4 in here quick. And you got 16, and 16 is 32. There. Now here's an equation. It's in rectangular. And here are the points that we want to do it from this to that. Then you can write a parametric for this. They usually call it a description. I sometimes like to call it a system of equations, but its better name is it's a parametric description. All right, so what do parametrics always have in them? X equals, y equals, and what's one more thing? T. And the T is like the x. Do you remember me saying that just a minute ago? The t is like x. When you're converting it from parametric to rectangular or vice versa, the x is like the t. So I'm going to highlight them in blue. That 1 and that 4 tell me that this should be between 1 and 4. Because x is like t. Now, you can do it another way. There is another way to make this, and I just don't want to try to show it to you because it'll really be complicated. You could make x be equal to 5t if you wanted to, but it would just make it really complicated, and why do it the really complicated way? If you let x equal t, then you can go back and figure out what this has to be. How do you think you'd do that? Only Jackson knows? Come on. Abby. Yeah, since x equals t, and you get to pick that, and I would always pick it to be that. Why make it complicated unless they make you? What if they said x has to be 2t? Well, then they already gave you one of your two parametric equations. But anyway, I'm going to stick in x equals t, and I'm going to stick it there and there. Yes, question? Because the other one was a straight line. This one's a curvy line between these 2 points. The other one was a straight line between the 2 points. Okay. Okay. So now I got x equals t, and I just have to stick a t here, and a stick a t there, and then that's all there is to it. 4t plus t squared. How do I know it works? You know, if your life depended on it, like, there was a guy. It's a little sidestep math behind it. I'll pause the video for a second. Okay, so this one was a parametric, and if you have to check it to make sure it's going to work right, maybe you'd want to, like, you know, the guy that was with the balloons, maybe you'd want to, like, make your teddy bear take off with the balloon first. Make sure your theory is like, okay, so my teddy bear weighs 1 pound, and it only takes 1 balloon. Well, then you can figure out how many balloons it's going to take to get you off the ground and all that stuff. All right, anyway, I'm going to check this thing to make sure I'm right, because my life might depend on it, or in this case, your grade will definitely depend on it. And you always go back to the TXY chart. The thing you got to be careful about is that your points have to work at t equals 1 and t equals 4. But there would have been another equation that would have also went through those points, but that equation wouldn't have had these squareds in it. You know what I mean? You could have made another equation that would have worked. So just because you put these numbers in doesn't guarantee you the right answer. But your answer is going to have numbers that are squared in it, so you know that yours fits this situation. All right, so I'm going to put in a t equals 1, and I'm going to see what I get. And then I'm going to put in a t equals 4, and I'm going to see what I get. If you haven't already done that, you should do it too. All right, if I put in a t equals 1, well, then x equals t, so x equals 1. And the same thing will happen with the 4. X will just equal 4 then. And then the y will be, let me think, if I put a 1 in here, I get 4 plus 1 squared is 5. And if I put a 4 in here, I get 4 times 4 is 16, plus 4 squared is 16, which is 32. And look at that. I hope these are familiar. 1, 5 was our starting. 432 was our ending. So we knew we were doing it right. What were the key elements? You had to set x equal to t. X equals t is a big deal. Now, one last thing. this set of parametric equations, x equals t and y was equal to 4t plus t squared, that needed a domain. Think close about what the domain would be. I'm going to give you the wrong answer. X was between 1 and 4. That was close. A lot of kids put that. X is between 1 and 4. No. Not for parametric. T is between 1 and 4. Do you get on parametrics? You need three things: an x equals equation, a y equals equation, and a t limit, or a t domain. Okay. Let's do one more of those. Y equals 3x to the third plus x from 1 comma 4 to 2 comma 26. Write an equation for that one. You might be like, that is an equation for that one, Mr. Surver. I want a parametric equation for that. Okay, how many of you knew this key little element that you should start with x equals t? Raise your hand if you had that one right. Okay, awesome. What if I say y equals, what am I going to put? Well, here's my y equals equation, but if x equals t, you just stick a t in there. 3t to the third plus t. That part's pretty easy. Well, what else do you need, Mr. Surver? I need a domain. And if you're doing a parametric, your domain's always going to be a t. It's between this and this. And since x equaled t, here's my x's. It's between 1 and 2. Raise your hand if you had that one right. All right. Now I'm going to stretch your mind. What if y was equal to... No, this is what's going to stretch your mind. What if x was equal to 3y squared? And I'm going to start with my y numbers and show you I'm going between 1 and 2 on my y numbers. They would have had this connecting word from. So what if x is equal to 3y squared from 3 comma 1 to 27 comma 2? Then you'd write parametric description. If you learned nothing else last week, I hope that you learned that there's always an x equals and a y equals and a t. And the t is between two things. But wait, this one's different. don't say x equals t. If you did that, slap the back of your hand or something, because it's y equals t. Raise your hand if you figured that out. Nice. Think about that. Yes. Okay, I'll double check it. Thank you. You're right. 27 does not work. Double checking that. 12. Sorry about that. 12 comma 2. Good catch. Okay. Why do we have to do it that way? Because we already had an x equation. You can't just change your x equation from that to x equals t. They're totally different. We didn't have a y equation, so we can make up anything we want for the y equation, and the simplest y equation we can write is y equals t. Okay, yes?
Couldn't you technically just solve for y?
Absolutely, you could. And let's just set that aside for a moment and see if you end up getting the same final answer that I do, okay? All right, so if I let y equal to t, I can just put a t right there. And then this will just be x equals 3t squared. And then remember, y is equal to t. I can totally see some kid, and I bet you somebody in here did it, putting between 3 and 12 when it should have really been between 1 and 2. How many of you actually put the right t? Okay, because remember the t is y. And so it was our y values here that would have to go in there. Remember me saying what you do to check yourself before you wreck yourself? Launch your teddy bear into outer space first, you know? They launched a dog. That was the first thing they put into outer space was a dog. And then I think it was a monkey. And then they went to the humans. All right, so we're going to check this thing, txy, and make sure that the points actually work out. And if our t is 1, what would the x be? 3 and 1. Ooh, look at that, it worked. And then if t was 2, y equals 2. And this would be 2 squared is 4 times 3 is 12. Cool. 12 comma 2, same point ahead here. 3 comma 1, same point ahead here. Looks like my equation's working. So final answer, y equals 3t squared, sorry, that was x equals 3t squared. And y was just equal to t. And my t limit was between 1 and 2. So you can switch the x and y around and it'll still work. Like last time we said x equals t, this time we said y equals t. All right. Now, I feel like that's a, I'm done, double check myself, make sure I'm not. I think you could do that. I think that's enough for one day. I don't want to melt your brains. We'll do more review on Thursday. So what should you do between today and tomorrow? And the next day? Because tomorrow is a Wednesday and it's a mask day. It's really not that complicated. I got a worksheet in there. Everybody find the worksheet. I think I made it visible right away. Can you verify that you can see the worksheet in there? Okay. Parametric equation worksheet. I'm going to try to post the key for that. And you guys see if you can handle doing it between today and Thursday. I know there's a lot of questions in there, but if you don't finish by Thursday, maybe I'll make it due Friday. But this is something that would help you a lot to get ready for this test. All right. And that's all I have for the video for today. The worksheet again is called Parametric Equation Worksheet, and it's in the folder for today, which is June 1st.